Hi, everyone. Welcome to the AWS Best Practices Summit. I'm John K. Waters, editor-at-large for Converge 360, and I'll be moderating the first of three sessions organized by the awesome editors of the 1105 Media news sites AWS Insider and Virtualization and Cloud Review. Our sponsor for this event is Veeam Software, provider of a single platform for cloud, virtual, SaaS, Kubernetes, and physical data management and protection. Before we get started, I need to go over a few housekeeping details. First, each of today's three sessions is being recorded. Keep an eye out for an email with a link to that recording within the next few days. Also, each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. You might also have noticed that our sponsor, Veeam Software, has provided some resources that can be found now on the right-hand side of your console. Please take a moment to check those out. And last but not least, during today's third session, we will be giving away a Nintendo Switch, the enormously popular hybrid gaming console. You must be present to win, so stick with us for the entire event. Now let's get to our first session. AWS Architecture and Configuration Best Practices. Our first presenter is Carlos Rivas. Carlos is a Senior Solutions Architect at Intervision Systems, an AWS Premier Consulting Partner. Over the course of his 15-year career, he has worked with large telecom providers, managing and configuring network devices, using a variety of tools and languages, including Java, Groovy, Python, Perl, and PHP. He also is a cloud computing instructor for both LinkedIn Learning and Udacity. I have worked with Carlos before, so I know we're in for an informative session. Take it away, Carlos.
Thank you so much for the wonderful introduction, and let's get rolling here. Today, I would like to talk to you about architecture best practices in AWS. So in that sense, we're going to cover architectural concepts that, get you off on the right foot in AWS. We're also going to talk about account management, because in AWS, you can have an account, you can have a dozen accounts, and it can turn into a mess very quickly. So I'm going to try to point you in the right direction there as well. Now, also, I'm going to try to cover a little bit about security and configuration, because those are key concepts that you need to understand early on. So those are things that you would do very well to set up as soon as possible when you're starting in AWS. And finally, I'd like to touch on infrastructure as code. Why? Because setting up infrastructure as code, you really only get one shot, because once you start deploying a lot of servers in your environment, it's really hard to go back and say, well, we want to turn this already existing infrastructure into code. It's a lot easier to talk about it now when you're architecting, when you're designing your very first footprint in the cloud, to do it as early as possible, and then from there, it just gets easier. But if you leave it for later, it can get a little bit complicated. So let's start right away talking about architecture in AWS. And I always like to start by defining what is it that I'm trying to get at. In this case, a definition of architecture that I found generally online, it says, is the complex or carefully designed structure of something. In this case, something for us means taking AWS services and components and just overall configurations parameters to create a solution that provides value to us in one way or another. Here's an example, and I don't expect you to understand this. This is just an overall example of architecture in AWS. In this case, I chose to show you what a WordPress hosting would look like. And this is using several services such as load balancers and traditional EC2 servers that you can deploy. My point in this particular slide is not really to get you to understand any of this stuff. It's more to say something like, hey, we have this option that is available to you in the AWS reference architecture, and you can choose to follow this step by step. really the point to take away from this slide is that never to really try to reinvent the wheel, because you're going to get best practices in pretty much everything around IT, and it's already out there in several documents. This particular document is the AWS reference architecture, and it just happens to be for a very popular blogging platform, if you will. So it will be the same whether you're trying to do something different. In fact, let me go to the next slide here and show you. This is a completely serverless solution. There's no EC2 machines, whether Linux or Windows, none of that. This is just using a normal AWS services that you would use, for your deployments. In this case, it's using events and Lambda functions and all that to create a solution for the business. So going back to my point here, these are the things that you want to understand early on, because this will help you get to where you want to get following best practices. So in this case, let's say we want to do a serverless solution. We will look for the reference architecture provided by AWS that follows best practices around serverless solutions. So yeah, that's really my point for you, is never really try to reinvent the wheel. There's always a document somewhere out there that can help you achieve your goals without much having to come up with ideas on your own and just developing on the fly, right? In fact, speaking about those documents, there's a URL for you, aws.amazon.com/architecture/well-architected. And this is where you're going to start pretty much any deployment that you have in AWS. This is going to be your starting point. And here you're going to find information around best practices, such as what do I do about security? How do I set up monitoring? How do I set up for performance? How do I optimize for costs? And those things I just mentioned are known as the 5 pillars of the well-architected framework. So let's go over each one of these. In fact, I could do an entire presentation just on these 5 points, but that's not the goal for today. So I'm just going to quickly tell you about this. For example, the security pillar, it tells you, hey, what are you going to do with your data? Does your data require encryption end-to-end? Does your data need to be backed up, or any of that? Do you need to set up disaster recovery and all that? When it comes to operational excellence, what this means is, what are you doing for monitoring your system? Are you able to maintain availability if you lose connectivity to AWS? And all those tools that help you achieve those goals are there documented in here. So like I said, you don't have to reinvent the wheel. The same for reliability. What if your system goes down? Do you have another copy ready to go? Do you have a passive active configuration or an active configuration to be able to provide service in case something happens? The same goes for performance. What if you plan for 100 users and instead you get 1,000 users at the same time? Is your system going to be smart enough to scale and handle that? So going over these documents, it will show you exactly what to do and how to react in those situations. In fact, some documents that they released recently, I believe less than a year ago, they show the actual structure that they have for the e-commerce site, Amazon.com, not necessarily related to AWS, even though that's what they use for their platform. They show you the exact practices they do on Amazon.com to be able to maintain reliability, even during those holidays such as Black Friday, when pretty much everybody is just hitting the website to the extreme. They know exactly what to do and how to scale and how to manage all this stuff. And finally, and this list is not exactly in any particular order, but I see that I put cost optimization at the bottom. That's just a habit that I have, and to me that's really important, just to be able to make sure that everything is in place. And once I have all the components in place, that's when I decide, okay, now it's time to optimize for cost. Now that I have everything working, what can I do to make this a little bit cheaper? So I usually follow these 5 pillars in this same order that I show in them here. Now let's switch away from architecture a little bit, and let's talk about managing AWS accounts, because this is a topic that's very important. That's somebody that's just getting started. Probably you go to AWS, you're going to put down your credit card number, and you're going to get an AWS account. So first, I need to define what an account is, because usually that happens that people don't really understand what I mean when I say AWS account, because the word account is just heavily overloaded. So an AWS account is nothing more than an environment where resources are going to be deployed. So this is when, like I said, you log in, you put in your credit card information, and then from there you can start creating networks, deploying servers, whether it's Linux or Windows, and doing any configuration that you want. This usually gets confused with a user account, which is a set of credentials associated with permissions to access an AWS account. So yeah, when somebody says, hey, I need an account, especially if you're new to AWS, and you say something like, I need an account, I usually have to try to understand, is he asking me for a username and password, or is he actually asking for a new AWS account? So that's where it gets confusing. And of course, to make it a little bit more confusing, which is what we do here, we have SSO, or single sign-on user account, which is a set of credentials from an external source using federation to access AWS. In this case, if you have a corporate Active Directory and you connect it to AWS, then you can log in using Active Directory into the AWS console. In this case, it would be an SSO user account or a federated user account. Moving on from here, the first tool I would like to mention in regards to managing accounts is AWS Organizations. AWS Organizations can help you centrally manage and govern your environment as you grow and scale your AWS resources. This tool in particular, what it does is, if you're going to have a ton of AWS accounts or environments, it will help you manage those in a very dynamic type of way. Let me show you this diagram here. What we have here is what we call the root account. For example, this is where you would have, let's say, your billing information. Everything gets charged to this root account, the one on top showing in red here. Then from there, you can create what is known as organizational units, and I'll explain that in a second. And below those organizational units, you're going to have the actual accounts. So let's go back to organizational units. In this example here, we have test and development, and we have production. So in this organizational units, you can set what is known as SCPs, or service control policies, which can apply rules or security restrictions to the accounts below. So for example, in the accounts that you're going to have for test and development, you can be a little bit more relaxed and let, the developers and tester, break things and deploy things. And it doesn't matter all that much, let them do whatever they need in there to be able to create the application that you're looking for. Now, in production, of course, you're going to have a lot tighter security and a lot more monitoring in place, and you're not going to have those relaxed rules. That's a completely different set of rules in there, not only around security, but around deployments and all that. So you will have a complete different set of service control policies applied to anything that you deployed under the production organizational units. Now, what is the goal here? You will have entire environments in AWS, known as AWS accounts, and these accounts are going to be completely isolated from one another so that developers can, test their infrastructure as code, deploy routing, break subnets and all that stuff. They can do whatever they need in their test environment. And once everything is in a way that you like, then you can go right ahead and tighten up those rules and move everything to production. And in production, of course, there's only one way to go, and it's deploying what you need, and that's it. There is no more, let me test this or that. No, there is no testing. So you have service control policies in place to make sure everything is tightened down there. And of course, you don't want to have to do all this stuff by hand. You don't want to do this manually. You would want to do it using something like this. It's a tool to manage this stuff automatically. So what benefits do you get? You have something like consolidated billing. which is having all these accounts bunch up together, you only get one bill at the end of the month, which is the one that goes to the root account. So you don't have to worry about, I have 50 accounts. Am I going to get 50 different bills? No, that's not going to happen. As I mentioned, service control policies, which means you can have rules applied to as many accounts as you need based on the organizational units. And of course, those OUs give you visibility into what is the purpose of the account. So if you have an AWS account, all you have is a number there. It doesn't tell you anything. But if you can see to which organizational unit it belongs, you can treat it accordingly based on, the rules that you have for that particular OU. Now, automation is really probably the most important one in this slide for AWS organization, is that you can create accounts just by a single click. It's really easy and just as easy to destroy them as well. And this is very, very important, especially in an enterprise where you're going to have dozens, even if possibly hundreds of AWS accounts for their various purposes. There is one more top layer that I would like to mention here, and that is AWS Control Tower. AWS Control Tower provides the easiest way to set up and govern a secure multi-account AWS environment called a landing zone. It creates your landing zone using AWS organizations, bringing ongoing account management and governance, as well as implementing best practices based on AWS experience with thousands of customers as they move to the cloud. So this is another layer of automation on top of AWS organization. This is great because all you do is come here to this particular tool, and it will help you create exactly what I just described. It's basically, it will create AWS organization. It will create the OUs that are commonly known around best practices, and it will set up pretty much everything for you, including AWS SSO, which we're going to talk about here in a second. But once you deploy Control Tower, you're going to get an account for, auditing. You're going to get accounts for managing your configurations and everything. It's just a set of best practices applied to AWS organizations. So if you have this layer on top of AWS organizations, this gives you even more leverage of automation, which is really what I'm trying to get at today. It's automation because automation promotes best practices. And that's what I want you to take away from Control Tower. Basically, you run this Control Tower, and it will do like CloudFormation scripts and everything behind the scenes to manage automation and do everything that needs to happen to get you to that beautiful organization setup with proper OUs and proper security hub configuration and all that. I want to talk a little bit more about Control Tower, and just because I glanced over SSO. Now, what they do here is they'll set you up with AWS SSO directory, so you have your own little directory in the cloud, but that's really not the point here. The point is that you would be able to take your Azure AD, which you probably have in your business, or your Active Directory. Everybody has something like that. No matter how small the business is, they'll have some sort of identity source on-prem. And this identity source, you can just connect it using, something like SAML compatibility here, passing the metadata to AWS. And then if you pass that information to Control Tower, that's when really things get very, very interesting, because now you can create roles and define permissions for those users. And it's just great to be able to manage an AWS environment while continuing to use your already existing identity management source without having to just create new users and deal with new password and all that. Nobody wants to deal with more password. We have plenty of those already as it is. So if you can reuse your identities in AWS, I highly recommend you do so, even if you don't choose to go the way of AWS Control Tower. So moving on from here, I'm going to switch gears a little bit to talk about security and configuration. This topic is also very, very important when it comes to best practices. It's not something that you want to just glance over. You want to keep this on top of mind at all times, especially when doing a brand new greenfield deployment. You want to be able to have this on top of mind to be able to say, okay, what am I going to do to prevent access to this and monitor all this access and properly configure my server, because you know how it is in the real world. You'll make a change, you'll go on vacation, you'll not remember that you made a change, and nobody else in the business is going to know that you made that change, and things like that happen. So it's good to be aware of configuration changes. So the first one that I'm going to ask you to do as a best practice is to set up CloudTrail as soon as possible. This is something that you would not have to do if you enable Control Tower, because it will happen for you behind the scenes. But if you have a brand new account and you haven't done this, I highly recommend you enable CloudTrail. So CloudTrail is a service that enables governance, compliance, operational auditing, and risk auditing on your AWS account. With CloudTrail, you can log and monitor and retain activity in your infrastructure. So what does this mean? If somebody makes a change on one of your servers or any of the configuration environment, it will be detected. It will be logged here. That's the purpose of this tool. Of course, I really don't want you to use this tool directly, but as we have seen, there's always a way to automate things. And why do I say that? Because if you have a horrible log file like this and you have to go through it, and there's thousands upon thousands of entries, it's really not fun to have to go through this particular audit trail. So I'm not going to ask you to do that. There are other ways around that. And that's why I like to mention AWS Config, which is a service that enables you to assess, audit, and evaluate the configuration of your resources, and it continuously monitors and records configurations and evaluates them against the desired configs. Let me explain this. What this will do is, using the CloudTrail that you enabled, what this will do is will look for changes happening in your environment as soon as possible. And when these changes are detected, you can trigger rules that are going to run against those particular changes. Let's say, for example, somebody just deployed a server, and it happens to be in one of your production accounts. AWS Config will detect that somebody just deployed a server, and you can have a rule that says, hey, we don't allow unauthorized deployments in production, and you will get an alert right away saying, hey, somebody changed something in your production environment, and you might want to take a look, okay? So those are things that you can do. In fact, they give you a nice-looking dashboard, and in this dashboard, you can see, hey, this resources are doing okay. This other resources are non-compliant. What would be an example of non-compliant? Well, let's say that you have a rule that says that every EC2 server that is deployed out there is going to have something like a tag, a tag that says this belongs to development, or this belongs to this person, and this is the billing code for this particular machine. That one is very popular, by the way, when we have this billing code associated with EC2 server, so that we internally can bill each particular department in the company based on their needs for compute power. So if you have resources that do not have these tags, you can come here and set up a rule in AWS Config, and that rule is going to detect that, hey, there's a server running that doesn't have the billing code. It doesn't say that whether it's development or test or production. And, you don't have to be super harsh and just go ahead and shut down the server, but you can find out who deployed the server and have the issue corrected. And of course, you will never know unless you have a tool like this monitoring the environment for you at all times. So it's really good to have this tool for monitoring purposes and looking for any and all configuration changes that you didn't authorize otherwise. Now, of course, as there's always is in AWS, there's another layer of automation on top of what I just mentioned. That's called the AWS Security Hub. The Security Hub is going to give you a comprehensive view of any security alerts and security posture across your AWS accounts. So instead of doing the whole CloudTrail and config thing, account by account, which can get really annoying if you have dozens or even hundreds of accounts, you can have all that centralized in a single account using AWS Security Hub. this is a really great tool, not only in the sense that it aggregates everything, but it has a ton of best practices baked in. For example, we just mentioned CloudTrail. One of the rules that it's available here in Security Hub is that make sure that CloudTrail is enabled, and make sure you don't have S3 buckets that are just open to the public, because that would be a security concern. And you can monitor all those things across your entire footprint just from this one screen. And to make it even more interesting, they make it like a little game. So for example, take a look at this. This is PCI DSS compliance. It's a set of rules that if you're running a business that needs to handle sensitive credit card information, they make it like into a little game where it gives you a percentage number of all the rules that you're passing in compliance. And of course, in this case, it says 81% in this screenshot. And I have to take a moment to tell you that it's really hard, if not impossible, to actually get all the way to 100%. It's like chasing, a goal that you'll never reach. And let me explain why. So let's say that you have an EC2 server, and this happens to be a public-facing web server. It's going to have, obviously, the port 80 open to the world, and it's going to have a public-facing IP address. So probably this PCI DSS compliance collection is going to tell you, by the way, you have this server that is open to the public. It can be reached from the internet. And it's also, this server has this rule, or this has a public IPv4 facing the world. And you're going to have to say, yeah, that's kind of the purpose of this whole exercise. That's what we're doing. So, it will deduct some points and here, so you will not have the perfect 100% score. But you know that the reason why that is because you need this server to be facing the public. It's actually a public-facing server. So just don't get too caught up playing this game of trying to chase a perfect score. You probably never get there. But it's good to know, they make it a little bit fun to monitor your environment so that it's not like a process that you're going to dread every single day of your life. So it's good to just, once you set this up, you can just come here every once in a while and make sure that you don't have anything in the critical stage, something like super obvious that needs to be fixed right away. So it's good to monitor your entire environment from here, especially if you have multiple people that can come up with ideas that are not exactly the most secure. So it's good to be able to monitor them and, keep everybody honest across the board. So, moving on to a different part of the conversation, let's talk about infrastructure as code. The reason why I bring this up in a conversation around best practices is because, like I said in the beginning, you really only get one shot to set up infrastructure as code. Because once you set up your networking and everything that needs to be in place is in place, you're going to start deploying server, you're going to start deploying services, and that's it. There is no going back to changing the networking. So it's a lot easier to do this once in the beginning, even though it's going to take you a little bit more time to set up initially. I know it's a little bit of a pain, especially if you have traditional networking expert on site that are not used to any kind of scripting or writing code or anything like that. So it's going to be a little bit of a pain to set up initially, but it's something that is important to keep in mind. Let's continue here. Infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files. This is what I meant when I say scripting. You'll have these templates that you can use, and these templates are going to be used to deploy resources. Say, hey, I need a VPC, a virtual private cloud, and in that VPC, I'm going to have this many subnets, and these subnets are going to have this or that routing. There's going to be a VPN to connect to our data center, and so on. Doing that in definition files, it's a lot better than just clicking your way through the console. Because the thing about clicking your way through the console is that once you do it, the next day you're not going to remember anything that you did. It's going to work. I'm not arguing that it's going to work, but you're not going to remember the exact change. And if you use definition files, you can enable version control on those files, and then from there you can keep track of every change you've done from the very beginning. So let's talk about some of the benefits, which I probably just mentioned already. It's harder to set up in the beginning, but it's a lot easier to maintain. So if you want to do a change later to an infrastructure as code, it's a lot easier to come to a file, make the change, and redeploy as needed, as opposed to, exactly, how do we do this? Because we can do a change, but we don't know what's going to be affected. We don't know, what we did before. So it's a little bit of a pain initially, but once you get it going, it's just perfect. And also having the possibility of doing version control, in this case, meaning if you use something like code commit or GitHub or anything that's Git compatible, you can create branches. I am a big proponent of having separate branches for development, branches for tests, and branches for production. And in these branches, you're going to keep track of all your changes, and that's great. Being able to say, okay, I need to add routing information because we just added a VPN. You can see that somebody changed the file. You can see the person who changed the file, and it shows the exact change that was made. So if something breaks, using version control, you can easily roll back the change and redeploy and then reassess the situation, in a more calm fashion without having your systems down or anything like that. Automation end-to-end is probably the biggest benefit of infrastructure as code. In this case, I'm referring to something like a CI/CD pipeline, because once you check in your code to version control, you can have an entire process automated to deploy this thing, as we'll see here in a second. Another thing that I like to mention when talking about infrastructure as code is that it's easy to replicate. What do I mean by this? Imagine that if you create an environment that is entirely scripted, and that's your development or your test environment. So once it's fully scripted and tested, you can just take that script to a production environment, and just in a single click, you can deploy the whole thing. And it's going to work because it comes tested from your lower environments. So it's a great, great benefit to have when it comes to these type of automation, because in AWS, the word is automation when it comes to best practices, so keep that one in mind at all times. Here we have an example of one of those definition files. This is called a CloudFormation script, and what we're looking at is deploying an EC2 server, and this server has certain parameters, like, hey, I want the machine to be an M1 small. Of course, we don't do that anymore, but let's just do it for this example. And we have security groups definition to probably allow access into this machine. We also define a specific hard drive, a capacity or something like that for the machine. And this is what I meant to say when I said that if you have legacy networking expert, they may not be comfortable configuring network devices using a text script like this one. It's not exactly the easiest thing to do in the world, especially if you don't have a computer software programming background, but just know that you have this as an option. It's very, very popular in AWS. Although these days, we seem to be moving in a different direction. And let me show you what that is. Here we have another example, very similar. This one uses the Cloud Development Kit, and this is one of the latest and greatest from AWS. The reason why they came up with this is because the CloudFormation is just a resource definition file, and Cloud Development Kit is an opinionated framework based on best practices. So in this case, if you look at the first line, it says BPC equals EC2 BPC, and it creates a BPC based on, it says here, max ACs equals 3. So what this is going to do is it's just amazing. It's going to create a BPC, and it's going to split it into 3 subnets. So it's basically doing the entire networking for you. You don't have to do anything. The defaults that are behind the scenes in the Cloud Development Kit are smart enough to make the calculations that you need to create those subnets. Of course, you still have granular control if you need it, but just know that this tool is opinionated and it's based on best practices in the industry. So just using this particular tool you're already halfway there when it comes to best practices. Of course, the downside of using a tool like this is that the Cloud Development Kit requires that you have a software development background. In this particular example, we're looking at Python code, but you can do this in other languages as well. For example, TypeScript is one of them, and then there's some others supported as well. It will be the same type of parameters. It just needs to be adjusted to whatever computer language is your preference. So now that we talked about infrastructure, we talked about the code to create that infrastructure, let's talk about the tools to make this thing fully automated. And those tools are Code Commit and Code Pipeline. Code Commit is a Git-compatible, fully managed private source control service, and Code Pipeline is a continuous delivery tool to build, test, and deploy your code. Just combining these two tools with the code that I just mentioned, you can create a fully automated infrastructure as code deployment pipeline. It's just great. Actually, I have an example here for you. This is what it would look like. For example, you have your entire pipeline created, and the pipeline will get triggered every time somebody checks in code, let's say in Code Commit or something like that, or maybe a file is uploaded to S3. And once that happens, you can have, a deployment take place, run a CloudFormation script, or go to code deploy and trigger a Cloud Development Kit deployment. So all those things will happen behind the scenes once you set it up the first time, and you'll get full-blown automation of your infrastructure as code. Again, something that may be painful and feels kind of a waste of time in the beginning, but you reap the benefits as you go along, especially once you have to redeploy the environment various times, or you have changes that need to take place. So moving on from here, let's talk about our closing points. When in doubt, always refer to the well-architected framework. Pretty much everything I just mentioned, you can find that document, the well-architected framework, and it will be talked about in there in one way or another, especially around the 5 pillars, about performance, cost optimization, reliability, security. And of course, if you have to choose one of those, stick to security first. But like I said, when you have doubts, there's always something going to be there. Or just Google AWS reference architecture, and you can find an architecture that they already released into the public that matches more or less what you're trying to deploy. It will never be exactly to what you're doing, but you can find most solutions that somehow a little bit as close as possible, I should say, to what you're doing. Now, I've been hammering about best practices around automation. So I should say that use the AWS console for monitoring and tinkering, but not for actually building, because of what I said. You will make a change, you go on vacation, come back 2 weeks later, have no idea what you changed, and then that change stays there forever. So it's something to keep in mind. Just make sure that you use the console for these purposes, and try to do everything scripted, if within reason, of course, but yeah, try to do everything as scripted and automated as possible. And as I mentioned, keep an eye on reference architecture, because there's always going to be one that matches exactly what you're looking for. So, I show you WordPress, and then I show you a serverless one. There's probably one for you if you want to I want to do a static web host using S3. There's going to be one for that. I can guarantee you that, using CloudFront for the distribution network, for example. So there's always going to be an option that more or less matches what you're looking for. So keep that in mind. Keep those reference architectures in mind. But above all, for best practices, keep an eye on the well-architected framework. And with that, if there are questions for me, I'll be more than happy to take them.
Thank you, Carlos. That was awesome. Let's get to some questions from our attendees. Remember, guys, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's go with this one here. Carlos, can I use social login providers to authenticate into AWS?
That's a great question. I remember I mentioned something around SSO and federated login. The answer is yes. I have done using a tool like Amazon Cognito, for example. Once you connect to Amazon Cognito, and I should say enable it, you can connect it with social providers such as using Google for login or using Facebook as a login provider. And the way that it works is that once everything is configured and connected, you would go to those providers, from the login page. You will get authenticated, and once the provider comes back to AWS and say, hey, this person is authorized, they are who they say they are, so this is a valid federated login, and then you will get temporary access, temporary credentials to access AWS, and then go into the console and do whatever you need to do. So it's certainly possible to use social logins with AWS as your login provider, although I still recommend that, at least for the purpose of business, to stick to something like Active Directory or similar, or Azure AD, for example. But when it comes to social providers, yes, it's absolutely possible to set it up.
Cool. Okay, here's another one. Carlos, what can I do to avoid hard coding credentials in my infrastructure as code?
That's great. Let me think about that for a second. There are several tools, but if we stick to the tools provided by AWS, I can think of two right now. Number one would be the parameter store within AWS Systems Manager. This parameter store is basically what you would use to put values in there and then say, hey, I want this encrypted value to be a password or something like that. And you can put those in there so that you don't have to use your scripts to actually hard code a password, which would be horrible, especially if you put it in a code repository that is seen by a lot of people. It's never a good idea to have a password visibly exposed like that. Another tool is the AWS Secrets Manager, and that's very similar to the parameter store. It's just that this one is specific to managing credentials. And not only that, I believe this one also has automatic rotation of passwords. So it will change the password for you automatically every, let's say every 90 days, for example. And these are tools that are just specific for this, and you can use it in a similar way. And again, the whole purpose is to put a reference in your infrastructure as code scripts pointing to these values so you can get them when you need them in real time, as opposed to hard coding values, which should never happen, especially if you're going to check them into a code repository.
Cool. Okay, here's a new one. Can you suppress some of the PCI findings?
Great question. There's various collections of rules to manage in Security Hub. And the answer is yes. I was describing like, hey, if you have a server with a public IP or you have an S3 bucket facing the public, you can go to a section there and say, hey, we realized that this might be a critical, quote unquote, critical warning that you want me to resolve, but it's actually allowed. So in that case, I would just go ahead and yes, there is an option where you can say disregard this in order to avoid affecting your score. I believe, yes, there is an option to disregard warnings.
Okay. Carlos, can I use JavaScript with the Cloud Development Kit?
Oh, JavaScript. I would not do that personally. I'm not great when it comes to writing code in JavaScript, but I believe AWS is more than happy to support TypeScript, which is essentially just a variation there. When using the Cloud Development Kit. I personally prefer Python. It's just more readable for me, and I've been doing it for many years. But certainly using a tool like that one is entirely possible, yes.
Okay. Can I use third-party authentication providers with AWS?
Let's see, third-party. Yes, I'm thinking of an example right now, and that would be Okta, for example. A lot of people use Okta because to provide multi-factor authentication. So yes, that option is entirely possible, and that the reason why is because AWS IAM is compatible with any SAML or SAML, any SAML provider. So something like Okta, which is a third-party authentication tool, can certainly be used to connect to AWS, and then you would get, just like I described, you would get a federated login in there, which will give you an IAM role, which is giving you a temporary set of credentials with an associated set of permissions that you can use.
Gotcha. Okay, here's one. How soon can I find out if there's a breach into my AWS account?
A breach, that's interesting. AWS Config and CloudTrail, they are as real time as they can be. They're not the fastest tool in the world, I'll tell you right now. So if I have to detect breaches in real time, I'm still going to recommend standard IDP, IDS, intrusion detection tool, third party. So yeah, I'm not gonna say, hey, don't worry, it's gonna show up in your VPC flow logs, or it's gonna show up in your AWS config or something like that. Those tools are great, but if you need to know right to the second that something irregular is happening, I would highly recommend a standard off-the-shelf intrusion detection software in this case.
Okay, here's a new one. Is there a framework with specific controls and steps on AWS to meet PCI, DSS, and HIPAA compliance?
What was the first part again? Sorry.
Is there a framework with specific controls and steps on AWS? I guess this attendee wants to find something to meet the PCI, DSS, and HIPAA compliance.
Let me address that in two parts. In regards to governance, there is a web page that I can't recall right now. There is a web page that lists all the AWS services and their compliance when it comes to governance. Because if you're going to be required to do HIPAA compliance, you're only allowed to use certain services in AWS that meet that particular governance. And there's a list that they provide that, hey, you can only use this and that services because these are the ones that are already being audited and approved for HIPAA use, for example. In regards to a framework, in AWS Security Hub, they provide that list or collection of security recommendations that need to be in place. And of course, they have the software to monitor it and also keep everything in line within those guidance. But they don't have like not that I know of that there's a way to actually enforce it. Like you could say, okay, deploy this config rules and make sure that everything is compliant because, you don't want an automated piece of software to be making changes to your infrastructure and you not knowing about it. So yeah, they'll just give you the recommendation. It's really up to you to manually go in there and say, okay, this is not compliant with PCI. Let me see what I can do to make it compliant. But there's not such thing as a tool that would actually force you to be compliant. They'll give you the recommendation, and it's really up to you how you handle
it. Okay. Same attendee asks, are there any native SOAR, that's SOAR functionality in AWS?
What was that acronym there?
SOAR, SOAR functionality?
I am not familiar with that acronym, so I'm going to have to.
Not either. Apologies to the attendee. Not sure about that. Let's see. Here's another new one. Let me read through it. Is there an AWS service that automatically maps out our current environment?
Oh, that's a great question. Let's see. There is one that is really, really bad, and I do not recommend. It's called CloudFormer. It's called
more of a warning than a recommendation.
Yeah, exactly. If I had to do that, you know what I would do? I would go third party in this case. So if I have to reverse engineer an environment, I would highly recommend something like Terraform. I believe Terraform can do that. The official tool provided by AWS called CloudFormer generates a a CloudFormation script based on existing infrastructure, but I really, really don't like that tool. The script is very unreadable, the one that comes out in the end, so I don't recommend it. So if I were in the need to do something like this, I would highly recommend something like Terraform to reverse engineer everything.
Okay. I think I saw a new question pop up, but I can't see what that is. You know, I've got one here in Spanish. I could take a crack at it. In Spanish,
Let me see if I can.
No es bueno. It's from, I think it's Narciso Morales. Yes, AWS tiene una hermana. Yeah, you better do this if you can see it.
Let's see. The question is if we have an MFA, built-in MFA authentication. No, la respuesta es que no. AWS no tiene esa herramienta. Tendría que ser un third-party tool en este caso. No hay una opción para ti, Narciso, en este caso. So, yeah, that's my answer on that. There's really not a third-party, not a built-in tool for server authentication. So.
Gotcha. Mm-hmm. Okay, let's see here. That's about the reference architecture. Okay, ask that. Sorry, I think we got to, social logins. Yep, we did that one too. Third-party authentication.
This was very popular today.
Yeah. There's, here's one. I hope I get this right. It's a CloudFormer, ampersand GT, ampersand GT, CloudFormation, why don't you recommend?
The reason why is because CloudFormer generates a CloudFormation script that is not very readable. It's not very intuitive to modify and upkeep going forward. If you need it in a pinch, you can certainly use it to generate a CloudFormation script of your entire infrastructure as code. But yeah, it's not something that I would recommend for okay, we have this tool, we have this script that's generated by CloudFormer, and just have it there as the definitely source of truth. I would much rather have a readable and maintainable script done by hand than use some computer generated code that is going to be horrible and harder to maintain long term. That's the only reason why I don't recommend it. It's not super bad. It's just not optimal, if I should say it that way.
Here's one. Is there a reference architecture for a multi-region solution?
For multi-region, yes, especially around disaster recovery. There's always a solution around that, especially if you want to back up data to S3 or something like that, and you need compliance. For example, I need this data to be in the East Coast because my business is on the West Coast, and we want to protect ourselves against losing our business data in case of natural disasters, for example. Yes, there's reference architecture for that purpose where you can set up some kind of deployment that goes across the multiple regions and across multiple countries if it's legally allowed for the data that you're managing. So yes, you can set it up. I've seen disaster recovery scenarios that use active-active or active-passive configuration across regions for the same reason that we're talking about. We could lose an entire region or entire AWS data centers, and your application will still function on the other side of the world if you set it up that way. So there's certainly plenty of those that you can find in the AWS reference architecture library.
Fascinating. It looks like that's all the questions we have time for this session. I want to thank our presenter, Carlos Rivas from Intervision Systems, for a great session, and our sponsor, Beam Software, for making it possible. We're going to take a short break right now. We'll be back at the top of the hour for our second session, Data Protection, Backup, and Resiliency on AWS. Take a minute to check out the resources on your console provided by our sponsor, and stick around for some more great content and a chance to win a Nintendo Switch. We'll be right back.
Okay, welcome back, everyone. Thank you for being here, and thank you to our speakers, my fellow moderators, and of course our sponsor, Veeam Software, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization Cloud Review, and I'm here to moderate the second session of our AWS Best Practices Summit called Data Protection, Backup, and Resiliency on AWS. Our speaker for this session is Stephen Smiley, AWS Solutions Architect with Intervision Systems. Stephen leads Intervision's AWS Security Consulting Program. He focuses on enabling innovation by making security fundamentals accessible and actionable rather than a roadblock. A former military intelligence officer, Stephen balances strategic and tactical thinking to help you accomplish your objectives. Stephen, it's great to have you here. Please take it away.
Great. Hey, thanks for having me here today. As he said, I work with Intervision Systems. I'm Director of Cloud Services over there. And I lead a number of our efforts, a lot of security consulting, AWS migrations, AWS cost optimization, and serverless application development. I've got a few of the AWS certifications to back up my expertise here. And feel free to reach out to me on Twitter or LinkedIn at Stephen Smiley. Happy to field any follow-on questions you have. Today, what I wanted to talk about was data protection in general. And this kind of spans the security topic as well as just operational excellence, right? So security is important because if our data is not available, then we've got a problem, and we want our data to be available to us in a few different ways. And so we're gonna talk about those different ways, and then we're gonna get into some specifics about the AWS services, where our data would reside, and how we can and implement those different techniques. In this discussion, I'm going to focus on the AWS native features. There are third-party tools, and I believe in the follow-on session after me today, they're going to talk about one of those, but I'm going to focus on the AWS native capabilities. And then we can have a discussion about the merits of those capabilities versus third-party tools, but my goal here is to give you a really comprehensive understanding of what it would look like if you just use AWS stuff, which I think for many people will be sufficient, unless you have, other considerations, and we can talk about some of those towards the end. So let's get into it. One of the fundamentals of data protection is this is a shared responsibility model, right? So AWS is going to take on some of the ownership of storing the data durably and keeping it available. But ultimately, you should remember that you're responsible for how you configure this. AWS is great at making these things accessible, but it's not always by default, right? So you have to put some effort and consideration into how you do that. And so we'll talk about how to do that here today. One of the other fundamentals here is classifying your data. And a lot of organizations make this a requirement, right, or a recommendation at a minimum. But in my experience, very few people really do classify their data. And I think it's because they try to set up complicated schemes. So my recommendation is if you're not doing any form of data classification, I would start with even a simple scheme. It really helps. If you can at a minimum say that your data is like public or for internal use or confidential, that's going to help you a lot with just understanding where does my data reside, where's my important data reside, and I think that initial inventory is pretty important, and I found that once you do that, everything else gets a lot easier too. Another fundamental is to determine your recovery objectives. And it's hard for you to do this if you haven't inventoried and classified your data, right? Because I don't know what my recovery objectives are because I don't know what my data is. So that's why we're going to classify it, and then we're going to try to think about, well, what do I need? And I'm going to ask you to be realistic about your needs here. People like to say, well, all my data is top priority. I need it all the time. That's maybe not true, right? If you've got image thumbnails, for example, that are smaller versions of larger images, those can be rebuilt, right? Maybe you don't need to recover those at all. You could just regenerate them if needed. In that case, cool. Now I don't need to worry about that. But if I've got data that is absolutely critical to have accessible right away, then let's build a system and a strategy specifically for that. And I would recommend that in your data inventory where you've classified your data, you should probably note what those recovery objectives are. And that'll help you understand your needs. And then the last one I have here is understanding your failure modes and testing your recovery procedures. Failure modes just mean what could happen, right? And what would that look like? If there was a availability zone outage and I lost access to this particular service, how would my application respond? Would it fail over, or would I just need to wait? Or, what would happen? Maybe there's a regional outage, right? Those are pretty rare, but it could happen. If my data is coming through Kinesis, and Kinesis as a regional service has an outage, how would my application respond? And then how would I respond? As a former military intelligence officer, one of my primary jobs was trying to think through a military plan and saying, what can the enemy do that'll disrupt my situation, right? And if you're not thinking through what your enemy, and in this case, enemy might just be chaos. If you're not thinking through what chaos could do, then you probably aren't prepared to respond to those things. And then, of course, untested backups really aren't backups at all. So you have to test those backup procedures and make sure. I think that's particularly important in AWS. There's lots of things that we'll talk about in the techniques where if you're not prepared to decrypt your data, well, you've got it backed up, but you can't access it because you don't have access to the right encryption key. So test those and test them regularly. And those are some important fundamentals here. Here are my personal bullets for what I'm going to do if I'm thinking about data protection in an environment. So this first one is I'm going to select and configure my storage services according to my requirements, right? I'm going to think about data availability. I'm going to think about durability, like how much of this data could I lose? And then I'm going to think about, do I need to replicate this across availability zones or regions or what? So that's one of the first things I'm going to think about. I'm also going to think about data retention policies. I don't want to protect and bother with extra data that's no longer needed. I don't want to be audited on that data. I don't want to pay for the storage of that data. I don't want to deal with it. So I'm going to automatically destroy data whenever it's not needed anymore. The other thing I'm going to do is I'm going to consider my data access policies and try to make those as fine-grained as possible. A lot of people say they do this, but they don't. They've got some limitations, but then they've always got global admins that can access everything. I would urge you to really consider which data needs to be protected, as we talked about with classification, and then really make sure that that's protected and limited just to the right people. And as much as possible, try to keep people away from data directly. The next one is specific to encryption keys. I want to protect my encryption keys from unauthorized use. I want to define key use policies that are pretty restrictive. And I really want to enforce the principles of least privilege and separation of duties. In the security field, we talk a lot about separation of duties, but I don't think we implement it as much as we think. And one of those ways with key policies is that we don't want the same people or machines that can administer my key from using it. I want to separate those. So if I've got a person who can change key administration policies, that person should not also be the person who's encrypting and decrypting data. Separate those, and you'll find that now it's a lot harder for somebody to take over one role and then have full access to your data. The next one here is to rotate your keys. It's pretty unlikely that keys get compromised, but if they do, you don't want them to affect all of your data. So think about rotating those to limit the impact. And then the last one is automated discovery and classification of your sensitive data. We're going to talk about that specifically here today with an AWS service, but if you are coming into a new environment and you're not really sure what you've got, it's a good idea to do a baseline discovery and consider kind of revisiting that on a regular basis. The other thing I want to point out here today is that this gets a lot easier when you use more modern AWS services. So we're going to talk about EC2 and RDS today and the kind of standard services that mirror on-prem capabilities. But if you modernize your workloads to particularly use immutable architectures, you're going to find this gets a lot easier. And we're going to see that as we go into the different services here. Serverless compute on Lambda is great. So we're talking about how more modern architectures make data protection easier. One of those ways is using AWS Lambda. When my compute happens within a very limited function, I am sure that that data is not sitting around on the computer. It's not sitting around on a block storage device, and it only is interacting with particular data stores. One of those would probably be DynamoDB, where it's very easy for me to understand the classification of that data. I don't have a number of complicated tables where sensitive data might be ending up by accident. Using containers on ECS, very similar story. As long as they're not storing data on that container, then it's made it a lot easier. And then if you are still doing EC2 instances, consider building golden AMIs. EC2 Image Builder is a really great service that you can kind of package together all of your different dependencies for your instances, and then it's an immutable AMI. It can run your application, and you don't have to worry about it accidentally kind of storing sensitive data on there. This EC2 Image Builder is very similar to HashiCorp's Packer tool, but it's built right into AWS, and it works quite well. You'll find that these approaches also increase security. If I've got a golden AMI where if I need to make a change to my image, I just make it through my image builder and push out a new version. I never needed to have SSH or RDP open on that instance at all. And there you go. I have one attack vector that is not open to somebody. I don't have to have a Bastion host on there. So using these modern services make this a lot easier. Here's an important definition that I want to talk about more because we use these terms interchangeably. High availability versus fault tolerance versus disaster recovery or business continuity. We use a lot of these terms almost interchangeably. And so I'm on a little bit of a crusade to try to help our industry use these terms in a more productive way. So when we talk about HA or high availability, what we're saying is that we want to aim for an agreed level of performance that's higher than normal. So I'm usually going to say there's a particular uptime, and I'm going to express it in a number of nines, right? 3 nines. That means that I can be down for almost 9 hours each year. That's not very much. But then when someone else says, okay, now my service is 4 nines, that's even less. 5 nines, 6 nines. Now you're getting into like really, really high uptime. But the important thing here is that you want to minimize outage, but some disruption is available. And my kind of mental picture of this is like a spare tire on your car. Yeah, you can pop a flat, but you can replace it pretty quickly on the road and keep going. You don't need to have tires you don't need to have a car that can tolerate, popping a tire and not even needing to stop, which is more akin to fault tolerance. So fault tolerance would mean that I can actually tolerate a fault in my system, and it would continue to operate properly in the event of a component failure. If I need to be fault tolerant, then failure of a single component is unacceptable to me. But this starts to make our systems a little bit more expensive and a little bit more difficult to engineer. This comparison for me is more like a airplane that has redundant engines. If one engine goes down, I don't have time to swap out an engine up in the air. I need to be tolerant of that failure. And so I might have 4 engines so I can run on one if that's needed. But just imagine how expensive that gets. And then the last term is disaster recovery. And this is more focused on the policies and the tools and the procedures that will enable us to recover our vital systems when HA and fault tolerance didn't work. This is more like the parachute in the airplane. I can recover the pilot. I'm not going to recover everything, but I can recover the pilot. That's the critical thing. And so you want to think about all of these and what are your requirements and engineer your systems accordingly. So how does that compare to recovery strategies? So here we've got a slide showing the spectrum of these strategies. On the left, we've got backup and restore. And this is where your recovery point objective and your recovery time objective is in the amount of hours. So that's recovery point objective, just to make sure everybody understands, is at what point did I lose my data. So if I can lose a couple hours of data, then that would be a few hours RPO. And then the RTO is at what time would I be back up and ready to go. So I've run my recovery and I've got my system working again. So backup and restore is for low priority use cases. I can just restore my data after the event, and the cost isn't that high. A pilot light strategy is where I need to be closer to tens of minutes for RPOs and RTOs. These are still core services. I can start and scale my resources after the event. And with a pilot light, what I'm doing is I'm kind of replicating data probably from one region to another region or a site to a different site. And I'm provisioning a copy of my core workload infrastructure so that I can turn it back on. But the only resources that I leave on are the ones that would need to support that data replication and backup. But everything else is basically switched off. So I just have this little pilot light keeping everything going, but I'm not spending all the money to keep all my servers running. And then a warm standby approach is I'm maintaining a scaled down but fully functional version of my workload. It could take traffic right away. It just can't handle as much traffic as my normal site. This is going to be for business critical services that are going to scale almost immediately, right? So as soon as I send traffic there, it's going to start scaling up. And then I can fix my other site and then scale back as needed, but I didn't have basically any downtime. And then the highest availability approach would be a multi-site, active. Both sites are always on. And this is aiming to achieve zero downtime. This is the most difficult and most expensive approach that most people don't need. I'm actively serving traffic from multiple regions. I'm constantly syncing data across those regions. I'm making sure that my conflicts are either avoided or handled, and I have to have complex ingress routing so that I know which site to send my data to, and to make sure that I'm only sending it to healthy sites. And if one site does go down, the other site needs to be able to scale up to receive the entire my entire set of traffic. So that one's really hard, and you probably don't need it unless you know you need it. So a lot of people say they want to do this. I highly recommend against it unless it's business critical. Okay, so let's talk about some of the AWS specifics here. One of the things that I see is underused is checking your personal health dashboard. If there's an AWS outage, and of course, big AWS outages are rare, but they do happen, right? They just tend to be limited in scope and resolved very quickly. So one of the things you should be checking is, does this outage affect me? And is the outage that I'm experiencing my fault, or is it AWS's? So the personal health dashboard is actually part of the AWS support kind of capability, but it integrates with AWS organizations. So if you've got a number of AWS accounts, you can see the events that affect all of your accounts in one place. And I've got a screenshot up here that's showing an EC2 operational issue that began on June 29th. I actually just took this a couple weeks ago, and it started at 11:40 with 57 seconds and ended less than a minute later at 11:41 and 51 seconds, where they had some network connectivity issues in between, in inter-region peering in the US East 2 region. So this will tell me that this affected any of my resources. And you can see there where it says affected accounts. In this case, I was not affected at all. But it sure is nice that I can take a look at this and say, oh, okay, this outage is affecting me, or it's not. And so before I initiate major recovery procedures, I should know what the source of the outage is. So let's talk about some specific AWS services and how we would approach data protection and recovery in those. Amazon S3 has to be the first one we start with, right? It's the logical place to send data, object storage, and it's Amazon's kind of flagship service. Actually, that was their first publicly available service. So one of the things that people talk a lot about with Amazon S3 for backup is Glacier. And I want to tell you from my lessons learned is that Glacier sounds great, but I want to caution you to consider the operational burden of retrieval and the cost per object transition. So I've done a number of Glacier retrievals, especially ones where people sent data to Glacier that were not me. And I got to tell you, it's pretty annoying, especially if you sent a lot of small files. You can't really restore via the console for a large number of files very easily. You can do 1 or 2 files, but if you're going to need to go into large numbers, and I've done a couple million, you definitely are going to need to write a script. And although there's scripts out there that'll help you get started, you're going to need to figure out how to filter those files by the ones that you need to recover, because you don't want to recover every single thing in your entire bucket, right? So think about that before you use Glacier, before you send things. My recommendation is to zip many files together and send that archive to Glacier so that you are restoring fewer objects, even though each object will have many files in them. And I want you to be very careful with the object prefixes that you use in your naming scheme. so you can filter as needed. A lot of the times this is based on dates, so be very careful to use the proper ISO naming format of ISO 8601, I think it is, so that you can filter that appropriately and it's handled by regex appropriately. Think about that before you start sending data, or it might as well just be useless. I'll also say that if you think you might be recovering this, I highly recommend considering the infrequent access tier rather than going to Glacier. It's half the cost of standard, but it still retains millisecond access. So that's a pretty big cost savings without the burden of Glacier. I mean, if you have to do like one Glacier retrieval and it costs you a few hours of engineering effort, you might have already like burned your whole cost savings on Glacier just from a few hours of an expensive engineer. And of course, the relatively new feature of intelligent tiering is the easiest way to do this. It matches the pricing exactly of the other tiers, right? So if it goes to an archive, a cold storage tier, it's going to match Glacier. And it makes it a lot easier to tier those. But the major limitation, it's got a minimum object size of 128 KB. So again, you want to zip small files together, and that will make it easier. So those are my kind of lessons on the job from using AWS S3 for backup storage. Now let's talk about using S3 for multi-region architectures. And I saw in the last session there were some questions about multi-region architectures. So I'm going to talk about some of them that I've done and that I've seen work effectively here. So S3 is pretty good for multi-region. If I want to replicate state across regions, S3 works pretty well here. But I want to point out that S3 itself is very, very durable. So multi-region is not needed just for pure backup. I mean, AWS is just not going to lose your data in a region. That's going to be durable, and it's going to be very available. But let's say I want to run a disaster recovery site in another region, or I'm doing a multi-region architecture where I'm serving traffic out of both of those regions, and I want to make sure that I have the same data available to those applications. Here's where S3 does really well. I can use the cross-region replication, and the propagation time is just 15 minutes. So I can write to one bucket, write to any bucket, and it'll appear in all of the other ones within 15 minutes. That's not so bad. One thing to be aware of is that as you add more regions, the number of configs gets a little bit more complicated because I need a replication configuration in each direction. So between two regions, I need two configs from one to the other and back. Once I go to 3 regions, now I need to do 6 configs. So I need to do them in all the different directions. And then if I go to 4, it's 12. So it becomes a lot. That's not that bad, but I've seen people try to do this manually and then miss one. And it's kind of hard to debug because it's like, well, which bucket did you write it to? And so just be careful that you cover all those different directions. Okay, the other topic with S3 is sensitive data discovery. And I want to kind of relaunch Macie into the world because it launched around 2019 and it was basically a disaster. Everybody laughed at Macie for extremely high pricing at $8 a gigabyte. The API that was available was really terrible. It didn't have great filter criteria. There was just a lot wrong with Macie when it came out. And it's actually not too much of a surprise because it was an acquisition and Amazon probably released it a little too early. But I want everybody to kind of revisit it if they think this is a good fit for them because a lot has changed. So the pricing has gone down from $8 to just $1 a gigabyte. That's huge. You can estimate the cost in the AWS console. By just going in and saying, before you turn it on, how much would this cost me? If you are going to automate around it with the API, there's an entirely new namespace called Macie 2, where all the SDKs work much better. And you can use the filter criteria right now. So you can say, all right, well, I want to do sensitive data discovery, but just on my public buckets. Because as much as it would be nice to say, I'm not going to have any public buckets, we all do for one reason or another. So let's just really be sure that I don't have any sensitive data in my public buckets. The one approach to do this that I see is pretty common these days is to do a one-time kind of triage scan and then schedule a weekly scan that just checks for the objects that were added since the last scan. And this way you can say, okay, on a week-to-week basis, I am confident that I don't have any sensitive data hanging out in public buckets, for example. It's also good to do internal buckets that are private, just to know if I've got sensitive data, but you don't need to necessarily do that for all of your data. The other thing to know with Macie is that the findings are surprisingly helpful. You might think that it's just going to say, okay, this object has sensitive data in it, and now you have to go figure that out. But actually, it helps. So it's going to give you a type. It's going to tell you, I found credentials, right? I found like private keys, SSH keys, or AWS secret keys. Or it'll tell you there's financial data, credit card numbers, bank account numbers, personal data, health insurance, medical identification numbers, things like that. And you can even write custom identifiers with regular expressions. You can use keywords, and you can even use ignore words if there's things that are in there and you want to ignore. So that's pretty helpful. Also, it'll tell you pretty specifically where in that document it found the data. So the column and row number for an Excel workbook, for example, that's pretty hard to do without an automated tool. It'll give you the line number in HTML or JSON, or it'll give you the page number in a PDF. That's really helpful. And now you can integrate it with Security Hub for manageable findings, and I recommend that you do that, because otherwise it's just going to be kind of a JSON output, and you're going to have to kind of read that manually. That's not super great. Integrate it into your Security Hub, and now you've got some clean findings, and you can go and mark them as checked and say which ones you haven't. So that's actually a pretty helpful service now if you haven't used it. Let's talk about some specifics about how to protect data in S3 from ransomware, because that's the hot topic in security these days, right? Ransomware, I don't want my data to get encrypted and held away from me, right? So S3 is actually a perfect place to put data that you want to protect from ransomware. One of those reasons is that it's only exposed via the API. There's no operating system that can be compromised. There's nothing else. So because it's just exposed via the API, we can focus our protection on our credentials and the permissions on those credentials, because those are the only things that are going to let anybody into S3. The other thing to know about S3 is that objects can't be modified. They can be copied, they can be deleted, but they can't be secretly modified and encrypted in place. So if I was an adversary, remember we talked about red teaming, this is an important exercise here. What would I do to inflict ransomware on somebody? Well, I could copy the object and use a different KMS key, but the problem is that KMS key makes it very traceable. AWS could potentially intervene. If you report it as abuse and they find that, they could get that data back for you. So that's not a very good technique. I could copy the object out of AWS, but then I would have to also delete the object, and delete objects as an API call is limited to only 1,000 objects at a time. So if you've got 1 million objects, that's not going to work very well. So I'm instead probably going to look at using a lifecycle configuration that will, delete the objects and delete all the object versions. So now that we know that the API calls, the first thing that I want you to be thinking about here is these are the permissions I need to both protect and limit, and I need to be notifying on them. If I'm putting my CloudTrail logs into a SIM system, right, security incident and event management system, then these are some of the events that I want to be watching. So how do I protect from this? Well, one of them is bucket versioning. So if I've got versioning on the bucket, then when the adversary tries to make a change, they're also going to have to delete the previous version, or it'll still be there. So that gives them one more API call. It makes their job much noisier, and it makes it just a little bit more difficult. The other technique is to use the S3 object lock feature, which means that you can write the object once and read it many times, but they won't let you delete it. That is pretty helpful for protecting the data, but of course it won't stop somebody from exfiltrating it to another environment. So that's how we protect. But how do we detect if this is happening to me? The number one way is guard duty. Guard duty is the intelligent threat detection service, and it's pretty good at detecting anomalies. But what I find is that a lot of people turn guard duty on, but they don't really monitor the alerts. And so that's one thing that I'm going to kind of urge you to do is if you are using guard duty, please make sure you're monitoring those alerts. They're going to the right people, and you can actually respond fast enough. You should also be preventing people from getting these permissions by using IAM Access Analyzer, and you should at least have your CloudTrail on to see, hey, did my adversary successfully copy this data first, or are they just bluffing? And then last is S3 does provide server access logging with even more detailed records. I don't know that everybody needs this on, but if you're doing really intense logging, that's where you're going to want to go. Okay, so let's keep going here. AWS Backup is the native service for data backups in AWS. It covers EC2, EBS volumes, RDS databases, Aurora clusters, DynamoDB tables, storage gateway volumes, and their file systems under FSX and EFS. One of the things about AWS Backup is that cross-account backups with encryption are possible, but they get really complicated, and I honestly don't recommend it. I recommend keeping your backups in the same account because that's where you're going to want to recover them from anyways. So that's one of the features that I kind of don't recommend using unless you really have a specific need for that. It gets more complicated. I also recommend using standard policies at the organization level, which will make it a lot easier for your subordinate accounts to just leverage those same policies, and then you've got a lot of consistency across your accounts. And then the other one is AWS Backup lets you configure notifications for failed jobs, and I find that these are really rare, but you should set those up using the kind of CloudWatch functionality so that you can know if something went bad, especially if there's a lot of repeated failed jobs. Now you know you got to go fix something, and it's better to figure that out early on. So what does it look like when I'm using AWS Backup? Well, here's a little bit of a preview. You can configure your policies with a given frequency and retention, and even if you want to do a cross-region copy. And then you just designate resources through resource tags. So I've got an example here showing a monthly on the third Tuesday of the month in a particular backup window. It'll spend 1 month in cold storage and retain for a year before it deletes. So that's a pretty easy monthly backup rule. And then what I would do is I would say use a tiered approach. So set up like monthly, weekly, daily, hourly, and then my hourly will include my daily, weekly, and monthly so that I get the retention periods for all of those. Because that's that's just maybe how long I want to retain those important backups. So set up your tiered approach there, and you should have good success. Configure notifications for failed jobs. We talked about this briefly, but this is what it looks like. You just set up an SNS topic, subscribe a email address, a phone number, for SMS texting, and then when you create a subscription to that SNS topic, you can just add this filter policy that says anything but completed. So if the status was not completed, if it was failed or anything else, then send a message, and we'll keep an eye on that. Okay, let's talk about backing up EC2 instances. The most important thing to do when you're configuring backup here is figuring out, do I need a full backup of the instance or just a snapshot of the volume? The AMI, the full backup, is going to have everything needed to launch a new instance. The instance role, security configuration, the security config, VPC, everything. So that's really great, but it's a little bit bigger and it's got more stuff. If I just need a snapshot of the volume, then I can grab just that volume, but I just know you won't be able to start a new instance off of that. You could start a new instance and then just replace the volume, and then you're good to go. So you just have to figure out which one of those is more appropriate for your situation. And then I highly recommend separating volumes on your instances for different purposes to support this level of backup. So you've got an operating system volume, a logs volume, applications, and data. Well, I just want to back up my data. I don't care about the logs. I don't care about the applications. I can get that from something else, or whatever your situation is. But if you separate those, then it's easy to target just the specific volumes that you want to back up. And then, as I said before, testing recovery here is critical. If the AMI you're restoring from has particular issues, you can't SSH into it for whatever reason, the recovered instance is going to too, right? It's not going to be any different. It's a block level replication. So test that to make sure that your AMIs are working just right. And then you should know that if you need to do a pilot light approach, we talked about the recovery strategies, pilot light, you can do that with the Cloud Endure service, which is now kind of owned by AWS, was acquired, and this is an approach that will continuously replicate your application and server in any server-hosted databases, right? So it's on EC2, not RDS. It replicates them all into a second region with a low-cost staging environment. And then in the event that you need to switch over, the recovery time is in minutes, and your recovery point is in seconds because it's continuously replicating your applications and data. The thing to know here is that it just doesn't mix well with anything that's non-EC2, right? So it can't even grab an RDS database. You can do that separately, but Cloud Endure isn't going to do that for you. I find that a lot of environments where we do a simple migration, we lifted and shifted their stuff all onto EC2. This is a perfect fit, and then we can build more cloud-native applications separately. But this is a good fit if you're just on EC2. With RDS databases, the thing to know is that you want a combination of full snapshots and point-in-time recovery. So you can do point-in-time recovery with RDS backups under their automated backups feature where you define the backup window. But AWS Backups also has the feature of continuous backups where it actually schedules the backup window for you. And both of these record changes over a period of time, and they have a maximum retention of 35 days. So these are for, all right, I need to just go back a few days and open up a new database with the data from that time. But keep in mind, you can't retain it for that much longer. So use full snapshots if you need retention for a lot longer, because you can keep those for 100 years, but you can only do full snapshots every hour. So use a combination of those. And to be prepared for recovery, you want to make sure that you'll be able to point your application to the new database, right? Because you're going to spin up a new one, not replace the existing one. So use a DNS name for your database so that you can just change it in the DNS and point all the traffic over. And I recommend using a short time to live on that DNS record so that it doesn't get stuck in someone's cache for too long. But you should also be prepared for some older applications in particular that won't respect your TTL. If you have to go multi-region with RDS, there's kind of two ways to do it. RDS supports a replica, and Aurora Global supports multi-region databases, and both of them have less than 1 second of delay for being able to read that data in the other region, which is extremely impressive, right? That's a lot faster than the S3 we just talked about, where it's got a 15-minute propagation. But in both of those situations, you can only write to one region. You just are reading in another region. In a lot of cases, that's okay if your application is just read heavy, but just understand that you're not going to have global database writes synced across regions with either of these. Aurora Global Databases do support automated write region failover. So I've got my primary where I'm writing in Oregon. That goes down for whatever reason. It can automatically fail over to Virginia, and now that is my write database. So that's possible, but you'll have to engineer around that. So that's the best way to do multi-region with RDS. DynamoDB tables, when we're doing backup here, it's actually pretty similar. So we can do point-in-time recovery with the same limitation of 35 days, and I can do full backup just like we did with RDS through AWS Backup. And again, I'm going to restore the entire table data to a new table. So it's not going to replace my existing one, which means, again, I need to prepare to redirect my clients. But because DynamoDB isn't a server, it doesn't have a DNS record that I'm going to swap it over with. So here, I want to redirect my clients by pointing them to something like the SSM parameter store, where I'm keeping that DynamoDB table name. So I can go into the parameter store, change the table name, and now my clients, when they go grab the parameter, they're going to get the new one. So that's how I would restore a DynamoDB table. And then if I need to do multi-region writes, DynamoDB is the way to go. Global tables support multi-region writes with less than 1 second propagation. So we talked about how this is made easier, but with modern services, DynamoDB is the way to go. You can do a multi-region architecture with DynamoDB as your main data store. It's shipping off longer data to S3 for multi-region replication, and so that works out great. So, in summary, AWS has great support for data protection and backup. As you can see, it's across all the services. There's lots of support across the board, but you have to configure this, and you have to understand what your needs are. So my recommendation is to find your important data, carefully plan protection of that data. Select and configure the right services, set up the permissions appropriately, and then test those procedures, right? So that's the key to effective data resiliency. As much as possible, build your new workloads around modern services, S3, DynamoDB, and Aurora, and it'll make your job a lot easier. And then I want to leave you with one last question, which is beyond data, think about your protection and recovery strategy to your application and infrastructure. Are you doing the same things with the rest of your application, or are you just focused on data? That's another topic for another time, but generally, are you prepared for an incident? These are all the same thought processes that I would go through if I was doing that for application and infrastructure. Okay, I know that was a lot of information, but hopefully I've stimulated some conversation, and I'm open to any questions you've got for me.
Okay, great job, Stephen. And we will take some reader questions. And I'd like to remind the audience that we can answer questions until about 5 minutes to the top of the hour in order to give you a short break before the next session, so send them on in. So turning to the Q&A box, let's see what we have. First question is, when does multi-region or multi-cloud make sense?
Yeah, this is a good question. I talked about some of the multi-region architectures here, but I generally would say avoid it if you can't. Multi-region's hard. It makes things more complicated. Redirecting your clients and storing the data in multiple places, it also just makes it more expensive. And if you've got issues, it's going to make it harder to pinpoint where those issues are. But if it's a business need for you, then I don't think you have to shy away from it. Multi-cloud, on the other hand, is kind of a difficult term. We often use multi-cloud to refer to a business that has, some applications in Azure and some applications in AWS. That's okay. Multi-cloud there, that's not a big deal. But do I need to have one single application span multiple clouds? Almost definitely not. I would say go multi-region first. Going multi-cloud for a single application is just not a good idea. It means that you're only going to be able to leverage the kind of lowest common denominator of each of those, which probably means I have to use, a container service that can, reliably run my container exactly the same way. And then all my data stores have to have the exact same APIs, which just isn't the case. It locks me out of being able to use DynamoDB, for example, and it locks me out of being able to use, Lambda, because Azure Functions isn't exactly the same. So I would recommend against that as much as possible. So multi-region.
Okay.
Yeah.
Okay. And here's another question about a recommendation. Do you recommend separate accounts for disaster recovery or backup environments?
Yeah, that's a good question, because in general, we try to segment AWS applications by accounts, right? Especially environments. So it might make sense to separate my DR environment or backups as well. And I think the answer is no. I wouldn't use a separate account. If I've got one account that's got an application, I want to keep its DR environment within that same account, because all my access, all the people that can access that account are going to need to access it when the event happens. I wouldn't make that too segmented and separated, especially if I'm confident in my identity and access controls that are protecting that account. When you go across accounts, you're going to run into all sorts of issues with, like, my KMS key now needs to be accessed from another account and so forth. It starts to break my boundary that I was kind of carefully trying to build. So I wouldn't go to separate accounts if I can avoid it.
Okay, great. Looks like we have time for one more question, and that would be, where do you see people go wrong with backup most often?
That's a good one. So as a consultant, I come in to kind of clean up a lot of people's messes, which I really enjoy doing. But one of those is that people configure a lot of backups. They kind of forget about them, right? They're paying a lot of money to store a lot of old data that they have no notes or annotations about what those ever contained. So they're afraid to delete them because who knows, somebody might need them. And then they also never test any of the recovery of those. And they don't have any procedure for how they would recover from it. So I come in, I find a million old snapshots, and I say, you're paying thousands of dollars a month for these old snapshots. Are we using these? And people have no idea. So inventory your data and figure out why am I keeping this, and then really test those recovery procedures. If you haven't done a recovery on that data in the last 6 months, it might as well be gone. So that would be where I see people go wrong.
Okay. Well, it looks like that's all the questions we have time for. So thanks again, Stephen, for an excellent presentation and answering those questions.
You're welcome.